Welcome to part 10 of Project E55 ASL, and this part is going to be about removing the supercharger from the engine and going with a custom intake manifold to replace it. Now, the reason I'm removing the supercharger is because, well, first of all, the engine has turbos with it, so it doesn't really need a supercharger. The turbos are capable of building more boost than the supercharger. The reason I kept the supercharger in my previous setup in the E55 was because the turbos were placed all the way at the back of the car, and supercharger was there to basically eliminate a bit of turbo lag, so it would turn on when the turbos were still spooling up, and then later on in the higher RPMs the turbos would completely take over. But the reason I don't want to keep it in this car is that, first of all, I don't think turbo lag would be that big of an issue. Secondly, the supercharger weighs 40 kilograms, so that's a lot of weight for a lightweight car like this. This car is only going to weigh 900 kilograms. Also, I believe moving to a custom intake manifold would also free up a bit of airflow, so the engine will actually breathe a little better. So for this video, I'm going to be starting off by removing the supercharger, and then I'm going to start off by machining the bottom part of the intake manifold, the part that is going to bolt onto the heads of the engine. After that, I'm going to be welding some intake runners to that part, and then finally making the plenums, the top part of the intake manifold, and then also bolting on a new throttle body and everything, basically completing the manifold. So yeah, definitely a lot to cover for this video. Let's start off by removing the supercharger, and then get to the rest of it. So removing the supercharger was easy enough. I just had to unbolt a few things and unclip a few electrical connectors and then remove the belts on the front of the engine. I didn't cover this in too much detail because I already made a whole separate video series on this engine when I was rebuilding it. So that covers everything from removing the supercharger to removing the crankshaft to putting all the engine back together. So I'll link that in the description below if you want to see the details on all this engine work. That video series already covers all this. Here's a look at the engine after the supercharger is removed. So this is the place where the manifold bolts onto. There's 10 bolts over here. And what my plan for making a new manifold is that I'm going to be starting off with this aluminum. And basically what I need to do is that I need to copy this pattern onto the aluminum, and then like this piece needs to bolt on here. So I'll have to do some machining on this piece to machine it in the exact shape of these runners, because this does have to be an exact match. It's not an exact match on the supercharger, but then again, if I make it an exact match, it will flow a lot better. My heads are also ported, so these are a little bigger than the factory size on these, but it's still not a significant difference. They're only, I think, about a millimeter bigger than what they were supposed to be. For machining the flange for the intake manifold, I started off by drilling a few holes. These are the holes using which this flange will actually bolt to the head of the engine, but I was using these same holes to actually mount this flange to my milling machine, so that's why I started off by drilling the holes first. After this, I just put the old intake manifold gasket over the flange, just so I had some type of reference where these ports will line up with the flange. And next I started off by milling the holes for the injectors, and also as well as the holes where these intake ports need to line up. After a bit of machining, I actually put these flanges on the engine just to make sure how these holes were lining up with the ports on the engine, and after that I just marked the exact shape of the ports and did some more machining using a finer end mill, just so that I could mill this thing more accurately to the shape of my final ports. And then after that I just used the Dremel to get rid of all the rough edges that the machining leaves. Here's a look at the aluminum after all the machining, and I know my machining isn't the best. I've definitely not done the best job, but the thing is that this thing is already the same size as the intake runner, so I don't want to Dremel this side anymore. I'm still left with these ridges from the machining, but I'm just going to leave it at that because I'll show you guys how this fits on the engine. I've already put the other side on the engine. I was seeing how it lines up with the ports on the engine, and it's a really good match actually. Like it's almost a perfect match already. And even the angle that this thing is coming out at is almost an exact match with the angle the port is coming out at. This outer side is actually slightly larger than the inner side. Like the underside of this thing is a little smaller. That's the side that actually is the same shape as those runners coming out. And then this side is larger because the intake runners that I'm going to be welding on here are actually slightly larger. That's why I've tried to make this one like the same shape or close to the same shape as the next part that I'm going to be doing, which is to weld intake runners on here. For making the intake runners, I'm just going to be going with square tubing, so I'm going to be using these tubes and then just welding them on the place where they have to go, because this square tubing is actually a pretty good match to the shape I have these place is machined in. For welding this, it is going to be a little tricky because over here it's going to be the most difficult part, because I have my injector over here and my weld can't go in this region. So what I'm thinking of doing is that I'm just going to weld it from all other sides, and for this side I'm going to weld it from the inside rather than the outside. So like apply the weld underneath, and then obviously I'm going to be left with a bit of leak, so I'm just going to seal that with using epoxy. What I could have also done is that I could have made notches in this tube so that I can actually like apply weld on the outside and then fill that notch and then apply the weld on the inside, so it's all like one constant bead of weld going around. But that's too difficult. I think my aluminum welding skills aren't that good to actually do it that way. That's why I'm just going to use epoxy in the end to seal it if any gap is left. So yeah, that's the plan. Let's start by welding these runners and then see how it goes. After all the intake runners are welded in place, I also plasma cut this sheet metal that needs to be welded above the runners. Here's a look at the welding after most of it is welded together, and it's definitely not looking too good. Like, these are horrible welds, and there's also some gaps over here, and I've been struggling with this spool gun trying to figure out what the problem is, and yeah, it's just a crappy product at the end of the day. That's really the problem. I've tried different settings. I've tried changing the wire speed, changing the gas pressure, changing the voltage, putting heat into it. Nothing really works with this spool gun, and I'll show you what the problem is with this spool gun. So the wire mechanism inside this is so freaking cheap. There's literally no control over anything. Like the wire speed, like this is how the thing draws wire. Like, it's completely inconsistent. Like, it speeds up and it slows down all on its own, and what happens is that when it slows down, obviously you don't have enough wire, and then it causes these gaps in the weld, and then it randomly speeds up and dumps a whole bunch of wire on the welds. And then the other thing is there is no control over the thing. Like, there's like, this is literally a fixed spring, and this is the cheapest wire mechanism I've ever seen in a freaking gun. So yeah, this is, I don't know, it's the only spool gun I believe that works with this welder. That's why I have to stick with this one, but it's an absolutely garbage product. So anyways, yeah, that's the reason behind the horrible welds. What I'm planning to do next is that I'm planning to grind these welds off as much as I can, just to make a nice smooth shape over here, because this part of the intake runners is really important. This, by the way, shouldn't be necessary. If I was using a better spool gun or maybe a TIG welder, the TIG welder would have been the best option for this. That could have worked out easily. I did have a few TIG welding options, but I'm just doing this in a bit of a rush. I've just have 2 days to finish this right now, so that's why I'm just using what I have. But yeah, definitely not ideal. This definitely shouldn't be happening. So after that, I took some time with an angle grinder and a Dremel and tried to grind away as much of the welds as I could. So after a bit of angle grinding and shaving these welds away with the Dremel, this is what it looks like. So it's a fairly smooth shape now, so hopefully the air might stay attached with the edges. The point of like smoothing up this side and also adding velocity stacks sometimes is that if you don't add velocity stacks, the air tends to bottleneck on the intake runner. Like, when the air comes rushing in from all sides, it like creates a bottleneck at this opening of the port. But what velocity stacks help do is they like nicely curve the air into the port so that the airflow stays attached to the surface of the intake runners, and it doesn't all rush towards the center of the opening. The reason I'm not adding velocity stacks for now is that it's just going to take a long time machining velocity stacks for each specific runner. It's not going to be too bad even without velocity stacks, because this is a turbocharged car after all. So now getting to making the plenums for the intake manifold. For the plenums, I'm thinking of going with the similar design as on the Supercharger. Like, basically I'm using this square tube, cutting it in a wedge shape and just welding it on here. That's because, well, partly because it's really easy doing it this way. It minimizes the amount of welding I have to do, and secondly, it's also that I'm planning to mount the throttle body somewhere over here in the middle of the wheel and pointing forwards rather than pointing backwards like it is on the Supercharger. The reason I'm doing that way is because later on, what you'll see for my charge piping, it's going to work out a lot easier if the throttle body is pointing forwards, because my charge piping has to come somewhere from there and then run into the intake manifold from the front rather than from the back. After that, it was just a matter of doing a bit more angle grinding to cut the plenums in their proper shape. And after that I bolted everything in its proper place. This was to make sure that everything does fit, and also to measure out the sizes for the middle part, the throttle body part. Once everything was clamped in place, I just used a marker to mark up where these tubes for the throttle body and everything line up with the plenum, so that I could plasma cut the plenums in that shape. Once all that was done, I bolted everything back on the engine. This was to make sure that when I tack weld everything in place, the bolting points of the intake manifold where it bolts to the engine actually do line up with the engine. After that, I had to take the manifold off one final time to finish up on all the welding and add all those bits that were not added before. After that, I also added these brackets on the sides for the bolting points of the injector rail, so the injector rail could be bolted in place. And next I also added this bracket for the throttle body, like the cable for the throttle body, because this throttle body is actually a manual throttle body, it's not an electronic one, which I'll talk about a bit later. Once all the welding was finished, I ended up applying epoxy over all the welds. At first I was thinking of just applying epoxy over a few of the locations where the welding was not too good, but then later I realized the welding was so freaking bad that I just ended up putting epoxy over all the welds. But then the problem was, after the epoxy was applied, the intake manifold looked so freaking bad that I ended up painting it, because I guess that was the only way to make it look a little better. Here's a look at the manifold after everything is complete, and I was just doing a quick vacuum and pressure test on it just to make sure that everything seals properly. So I've just covered everything with duct tape and also put duct tape underneath so everything is closed. And yeah, I was just giving it vacuum and pressure. I couldn't test it under too much pressure because the duct tape comes off if I give it any pressure at all. But yeah, at least under vacuum it is holding vacuum, and it's not leaking from anywhere, which tells me that everything is good for now. So now the only thing left to do is to bolt this manifold to the engine and hope that 100 shot of nitrous doesn't blow the welds off my intake. Here's a look at the intake manifold after it's all bolted together, and just talking a bit about why I went with this design and why I chose to place all these components where I did. Well, first of all, the design is basically just, it's pretty much the same design as the design on the Supercharger, like the Plenums on the Supercharger. So on this one you'll see the same design, that the intake runners come up from here and they go into these two plenums on the side, and then these plenums actually, the only difference is that these plenums are going to the intercooler, and the air actually comes from a throttle body that actually feeds the air through the supercharger, then through the intercooler, and then comes up through these plenums and then into the engine. What I've done simply is that these two plenums are basically shaped the same way as the plenums on the Supercharger, but rather than a Supercharger being in the center, there's just a throttle body right here. So the area just comes in from the throttle body, and then it's fed to these plenums, and then it goes to the intake runners from where it goes into the engine. The only difference is that I've used all square tubing, whereas their shapes are a lot better. They're actually cast aluminum. They're casted in the exact shape it needs to be. So obviously using rectangle tubes and making air take these 90 degrees bends isn't the best in terms of airflow. Like, it does create a bit of restriction, but then again, it's not going to be too significant in a turbocharged car, and also because all these runners are extremely oversized, even compared to the supercharger. The my intake runners and everything are a much larger size than they need to be, so hopefully the restriction is not going to be too bad. The reason I did keep everything the same shape and everything is that in terms of placement, like in terms of how the injector rail and everything bolts on, that worked out really well, because obviously this is the same injector rail that was being used with that supercharger. And also in terms of like where the throttle body is placed and everything, this design works really well, because you might ask why I chose to place the throttle body at such an awkward location. Why not move it to the front? Well, the main reason was visibility. Like, out of the car, this thing needs to be fairly low, so that when I'm looking at everything from like the driver's view, this manifold is actually going to be pretty much below the view of the driver. But if I were to move the throttle body, like let's say to the front over here rather than at the back, that would have meant that I would have had to make these plenums higher at the front, and of course the throttle body would have been over here, so all that would have been in the view of the driver. And also later, if I planned to cover the engine, that would have made it a lot harder covering the engine, because the whole bodywork would have needed to be higher. So that's why this shape definitely works out better in terms of that. Also, you guys might be asking why I went with the manual throttle body rather than an electronic one like the E55 had. And the reason is just for simplicity, because later I'm going to be moving to a standalone ECU, an AEM Infinity. And this cable, yeah, it's just going to make things a lot simpler. I wouldn't have to worry about the pedal box. Like, I'll just need an accelerator cable running from this to the pedal box, and it's really going to simplify things. Basically, I won't need a sensor in the accelerator and like actually program an electronic throttle body and everything. The AEM Infinity is actually, like, it can be used with an electronic throttle body. It is able to control it, but this just simplifies things. It's going to make things a whole lot simpler. That's really the reason why I went with this one. I've also added these 4 vacuum hoses, or these 4 outlets at the back, and the reason for these is one of them I'm going to be using for the MAP sensor, the manifold pressure sensor. The other one is going to be for my boost gauge, or boost or vacuum gauge actually. So there's going to be one line going all the way somewhere inside the car over there, where there's going to be a gauge that's going to tell me my boost pressure. And then the other 2 are extras for now, but later I might use them for controlling solenoids or whatever I might need to control later. It's always better to have extra vacuum outlets in a manifold. There's not going to be any power brakes or anything in this car, so there's definitely no need for larger vacuum outlets like you need for power brakes. The brakes in this car are going to be manual, which I'm going to later get into when I make the pedal box for the car. The other thing you might have noticed is that there's these 2 bolting points on this manifold over here where there's nothing bolted to right now. So you might be wondering why I added these bolting points over here and made this whole like bottom part longer than it needs to be. Well, the reason is that there's this structure that has to go at the front over here that is going to extend all the way till the front part of the chassis, where this chassis is going to bolt to the engine, because I did need bolting points on the front of this engine, but there is no bolting points strong enough on the timing cover or anything, so I couldn't have bolted the engine from the front using the timing cover. That's why you left these 2 bolting points for that, for the purpose of actually bolting this engine to the chassis from the front over there, which is basically there for adding a bit of chassis rigidity. And also there's going to be 2 more bolting points at the bottom of the engine, like where the oil pan is. So that part, I was hoping to get to that part in this video, but that is something that hopefully by the next video I will also try to complete that as well. Also, another thing about this throttle body is that, well, actually the orientation that this throttle body is supposed to have is it's supposed to be mounted horizontally. Like, it's supposed to be opening in this direction, but I've actually flipped it over. I've actually used it this way. So like, this is actually not the correct orientation to use it like for like an application like this, because what can happen is that, let's say the throttle body is open midway or something, it would tend to push the air more towards one plenum than the other, but it's not going to be too big of a deal at the same time, because this tube is pretty long, so the pressure is pretty much going to even out by the time like the air flows to the back and goes to both these plenums. And even if it doesn't, it's not really going to be a significant issue, because each bank on this engine does have its own oxygen sensor, so it's not going to be like if more air goes to one plenum, it's not going to really lean out that bank of the engine, because each individual bank is being controlled separately by the ECU. So yeah, that's not really going to be a big problem. The reason I had to flip the throttle body this way is because there was really little space between my 2 plenums. If I kept it this way, it would have literally been impossible fitting a throttle body this size into this intake manifold. But the benefit of this design is that, well, it really simplifies things. Like there's a whole lot of open space in the engine. If I want to change my knock sensors, I can actually do them without even removing anything. If I want to remove my injector rail, it's super easy now. If I want to unbolt the whole intake manifold, I don't even need to remove anything, not even the injector rail actually. All the bolts are accessible, so literally doing anything on this manifold is going to be way simpler than it was before, or it was on the E55. So yeah, that's really one of the benefits, and that's really the benefit of this whole car. Really, that's the thing that I've done. I've made everything really simple to work on, since this is a time attack car, and since there are going to be things breaking on this car from time to time, that is one thing that is really important to do in a track car, to make everything really easy to access and easy to replace. Also, in terms of how the charge piping will work out, this will actually be a fairly good design, because there's just going to be one 4-inch pipe coming from here that is going to then merge into two 2.5-inch pipes that are going to bend this way, and then those pipes are going to go all the way down to the intercoolers that are going to be placed over here, and then yeah, the turbo is just going to feed into the intercoolers from there. So it's going to be a really short path from the turbos to the intake manifold. Also, to answer some of your questions from the previous video, a lot of you guys had questions about the cooling system and about the radiators, why I decided to place them horizontally rather than vertically. Well, the thing, it looks weird right now because all the ducting for the radiator is not in place right now, but what you later see is that there's going to be a duct coming out from the front, like that is going to be around like this height, and the splitter of the car is pretty low, it's like this height. So the opening at the front actually works out to be quite a big opening, like it's pretty much the same size as the opening on the front of the E55, and in fact the air would probably flow better through this radiator than it would in the E55, because in the E55 most of the part of this radiator was covered by the front bumper and the crash fracture that and everything that pretty much goes in front of the radiator in that car. Whereas in this car, when you look at the radiator from underneath, most of the surface of the radiator is all open, meaning that all the air that is going to go in from this duct and then go up through the radiator, and then there's also going to be a big vent over on top of the radiator where the air is going to exit out from. Yeah, overall, basically in terms of airflow, it works out a lot better than it was in the E55. Lastly, I wanted to give you guys a big thanks for all your support with the channel, because my channel just hit 30,000 subscribers since the previous video, which is actually a pretty big number. I never expected to hit 30,000 subscribers, so yeah, big thanks for all your support. The content should also be getting a lot better, like coming over the next few months, because, well, the next video is going to be about finishing up the rear section of the car, like completing the rear structure of the chassis, and then getting to installing the differential, making the prop shaft, and then finally even getting to the rear suspension, the multi-link suspension at the back end. After that, the structure of the car is going to be pretty much complete, and once the structure is complete, then I'm going to be getting to the electronics, the fuel cell, the pedal box, and all those other minor things that the car would need before it can be drivable. But believe it or not, after all that is done, the car will already be drivable, and yeah, that's the part I can't even wait to get to. And obviously, even after that part, there's going to be a lot more work that will need to be done, like all the fine-tuning of the suspension, adding anti-roll bars, like figuring out the spring rates, the damper settings, the aerodynamics after that, all the body work and all those things, and even finally getting to track testing the car, figuring out all the suspension angles and everything. So there's definitely a lot more content that is going to come over the next few months. On top of that, I was also thinking, if you guys want to see more videos on some of my other cars, I also have a CL55 and an SL500. So if you guys want to see any content on those cars, I can definitely try to upload content from those cars too. The CL55, actually, I was thinking I'll probably do a review on that car pretty soon, because that car might be gone soon. It's actually not my car, it's my brother's car, and he's not in the country. He hasn't been in the country for a while, so the car is just standing. So yeah, that car might be gone pretty soon, so hopefully I'll try to make a video on that in the next week or so. Also, other than that, I can also cover racing events and stuff if you guys want to see any content on that, because I do from time to time go to racing events, and also some of my friends also have some really cool cars. So yeah, let me know what type of videos you guys want to see, and hopefully I can focus more on that. But yeah, anyways, this is all for now. Thanks a lot for watching, and see you guys in the next one.